Welcome to the video lectures on analog electronics. Myself, Dr. Shoumik Poddar, Assistant Professor, Electronics and Communication Engineering Department, Guru Nanak Institute of Technology, Kolkata. The course code is EE303. Contact is 3, credit is 3. Today I will discuss the part 1 of module 4. Before going to detailed discussion of part 1 of module 4, let us have a look into the lesson plan of this module. The topics to be discussed are feedback amplifiers and oscillators, into which I will discuss feedback concept, negative and positive feedback, voltage or current and series of shunt feedback, Barkhausen criteria, RC oscillators, phase shift and wein bridge oscillators, LC oscillator, Colpitts, Hertless and crystal oscillators. The instruction hour is set as 5 and the corresponding course outcome is CO3, that is, after studying this module, the student will be able to analyze the different feedback mechanism in transistor amplifier circuits. The prerequisites for this module are fundamentals on Kirchhoff's voltage current law, Thevenin's theorem, BJT fundamentals and matrix. So, in part 1, I will discuss the feedback concept, negative and positive feedback, voltage series feedback, voltage shunt feedback, current series feedback, current shunt feedback, and finally the effect of feedback on input and output impedance. So first, we will clear our concept about feedback. In the previous modules, we have just analyzed common emitter or emitter follower amplifier circuits. There are different parameters, derivation and analysis. Then we have also studied the cascaded amplifiers like RC coupled amplifier, transformer coupled, and the derivation of voltage gain, input impedance, output impedance of the cascaded one also. But in practical situation, all the amplifier circuit are not stand-alone. Means they are utilizing some sort of feedback mechanism in order to regulate its voltage gain or the current gain, whatever it may be the amplifier type. So feedback is very, very essential to control the gain of the circuit, as well as it has several advantages over the without feedback circuit. We will clarify, we will discuss, and we will understand when we are moved to the next slides. So first, we will see the block diagram of a feedback amplifier. First, the triangular shape symbol is the amplifier. It is our practical amplifier, means either it may be a common RC coupled common emitter amplifier, either it may be a transformer coupled amplifier, either it may be a direct coupled amplifier, or either it may be a emitter follower circuit, either it may be a common base amplifier, whatever it may be. Now we will see that the output of the amplifier, that is V0, is taken to another circuit. This another circuit produces some sort of output depending on the actual output. So the another circuit output is known as VF, let. I have applied a original sine wave or alternating signal, which is designated as Vs. So Vs and Vf will be compared with each other, or we can say that their comparative result will go to the actual amplifier, then it will produce the necessary output. So therefore, thus the output voltage will be regulated by this feedback amplifier. Now here, this circle is nothing but an error amplifier, or maybe a comparator, which basically compares the input signal as well as the VF signal. Now, if the VF signal is connected to the negative side of the comparator and the VS is connected to the positive side of the comparator, then VI is equals to VS minus of VF. So in that case, this feedback circuit is called negative feedback circuit. That means the effective input is less than the actual input signal. That's what is called the negative feedback. But if this VF signal and the VS signal will be connected to the positive side of the comparator, then their additive signal will go to the main amplifier. That means the signal for the amplifier, the input signal for the amplifier is much higher than the actual input. So in that case, the feedback mechanism is known as the positive feedback. And we will study the effect of the positive feedback in the next part. But today we will discuss only on the negative feedback. Next point is that the extra circuitry which produces some fraction of the output signal is called the feedback circuit, and this beta is called the feedback factor. That is, V beta is nothing but equals to V naught by VF. So this circuit will produce some sort of signal from the resource mother signal V naught. So therefore VF must be lower than that of the V naught. So the fraction is called the feedback factor. And this A is the amplifier gain. So A into beta is called the loop gain, because if you see, it is a loop. It is a closed path, so it is called a loop, and the total loop gain is the A beta. Now Vs is the external input voltage, V naught is the output voltage, Vi is the input voltage to the amplifier, A is the amplifier's open loop gain. Now this is a very significant term, open loop. Open loop means in the earlier modules we are not observing any feedback path. So that means there is no closed path. Whatever we are applying the input will be amplified by the circuit and it will produce the necessary output. So it is a direct path, means there is so it can be called the open loop system. But when we are adding some extra circuitry which will check every time the output signal and it will produce some sort of fractional value to control its input, this is known as the closed loop system. So the closed loop gain will be the A beta. Negative feedback is realistic. It's a very fundamental thing that in our nature, in our human system also, the negative feedback is really realistic because it will control our emotions, it will control our behavior, it will control the natural laws. So therefore, without negative feedback, the entire system will be unbounded and it will be completely unstable also. So therefore, to make a system, whatever it may be, electronic circuit or a human body or some other one, the negative feedback must be essential to regulate the entire operation of the system. Now in the negative feedback, there are several advantages are data stability in voltage gain, because the fluctuations of the may actual external signal will be controlled. Improve frequency response. We will see how the frequency response will be improved in the next portions. The third one is the reduced noise, because very simple idea, as we are using some feedback path, so therefore if noise is generated, it also coming to the, it also going through the feedback path, and it will be checked with the input signal, and it will produce some sort of the output. So thus we can easily check the noise. And linear operation, more linear operation, because every time we are cross checking the output variations. So if there is any harmonic distortion or amplitude distortion in the output, automatically it will be checked by this feedback circuit, and thus the input signal will be controlled. Now the feedback topologies. In negative feedback, the four topologies are existing. The four topologies are voltage series feedback, voltage shunt feedback, current series feedback, and current shunt feedback. So this is the circuit block diagram of the voltage series feedback. Next one is the voltage shunt. This is current series feedback, and here the current shunt. I will discuss every block minutely. First, in our introduction, we have seen that this is the amplifier, this is the feedback circuit, this is the comparator. So now we are going to this different topologies. This is our actual amplifier, it is the feedback. Now first we have to understand what is the meaning of voltage series. Voltage series, the first term is voltage. So the first term basically introduce the output signal. Which type of output is current or voltage? So voltage stands for the output, and the series stands for the comparator type. Either it is the series comparator, means series comparator, or is a parallel. So the series denotes the input side, the voltage denotes the output side. Now as we know, the feedback circuit produces some sort of signal from the output, and that signal will be treated as the input of the amplifier. So we must be aware of this series term. Series means some two quantities or three quantities are in series. Now we know that as our input side, there is a variation or there is a disparity between the two signals. So if the input side is series, then we know that only voltage signals are different in type in case of series connection, whereas the current signal is completely same in the series connection. So in voltage series, what is happening, the output signal is voltage and the input signal is also voltage due to this series term. So therefore what is happening, our main signal is a voltage signal Vs, which is connected to the amplifier, and the amplifier is producing a output V0, which is connected to the feedback circuit via the shunt position, because the same voltage must be delivered to the feedback circuit. So how the voltage will be delivered equally? If we take the capping, means the shunt position. So in the shunt position, the voltage remains same. Therefore, the output section is the shunt. Now, this circuit is producing a voltage due to this series. So therefore, this voltage is in the negative direction, negative terminal, and this positive is in the actual input signal. So therefore, this connection is nothing but the negative feedback, and it is a series connection. So the amplifier gain A is nothing but V naught by Vi. Why Vi, not Vs? Because Vi is the actual input of the amplifier, whereas Vs is the original input signal. So Vi is obtained after cross-checking the Vs with this feedback voltage. Therefore, A is equals to V naught by Vi. Similarly, the beta is equals to output by input. What is the output? Output is a voltage. Input is also a voltage. So VA by V naught. So this is the voltage series. Next one is the voltage shunt. Voltage shunt means the output is voltage. Shunt. Shunt should be the input side. Now we know that during the shunt connection, voltage remains same. So we must discard this voltage, and current will be different. So we must take the current signal. So in this circuit, in this feedback topology, the input signal is current, whereas the output signal should be the voltage. See here, it producing some sort of output. It will be shunting to the feedback circuit. It will, but the feedback circuit will produce some sort of input current, some sort of current. So our main signal is an external IS, current source IS. It will delivering a current II to the amplifier, and the rest portion is going to the feedback circuit. So therefore, I can say that the A, which is the amplifier gain, is nothing but the V naught by II, whereas the beta is equals to IF by V naught, because the feedback circuit is producing the current from the voltage. Next one is current series. Current series means the output is current and series means the input. So the input signal must be voltage. So at the input side, the voltage signal must be present, whereas the output side current signal will be present. Now let us have a look. Again, the amplifier is producing some signal. Which signal? Current signal. Now we know, as there is a feedback circuit, the feedback circuit will take the entire output signal. As the output signal is current, so therefore it must be connected with the feedback portion, feedback circuit via series connection, not the parallel connection. So you will see that the current is flowing through the load resistance and going to this feedback portion. So after feedback, it will produce some voltage due to this series term, and it is our external voltage. So their subtraction will produce the actual input of the amplifier. So the amplifier gain will be equals to I naught by VI, because I is the current now. So I is the output current, so I naught by VI. And the feedback circuit will produce some voltage from current. So beta equals to VF by I naught. Lastly, we will study the current shunt. Here the output signal is current and shunt is also current. So the input side is also the current. Therefore, the output signal will be same that of the current series. But here, due to the shunting path, we are using an external current source. One portion is going to the amplifier and the rest portion is going to the feedback circuit. So amplifier gain can be written as current shunt. So I naught by II, whereas beta is equal to IF by II. So this is a purely current transmission. This is a voltage transfer. It is it is some hybrid, that is from voltage to current, current to voltage, and it is voltage to current. So these are the cross couple, whereas these are the straightforward feedback circuit. Now we will see the different types of topologies and their voltage gain, their feedback factor, and the gain of the with feedback. So first one is the voltage series. Again, I am telling voltage series means output voltage, input voltage. So gain without feedback, A equals to V naught by Vi. For voltage shunt, output voltage, input is current. So output, so gain means output by input. So output is voltage V naught, input is current shunt. So it is II. Current series, output is current, series is voltage. So input is voltage. So gain equals to output, that is I naught by Vi. Current shunt means both are current. So gain equals to I naught by II. Now feedback factor, in voltage series, this voltage is again transformed to another voltage. So beta is Vf by V naught. In voltage shunt, the current is converted to the the voltage is converted to the current. So beta equals to If by V naught. Always remember, when feedback factor is calculated, always look into the shunt position, because the feedback is sending to the input. That's why we are always concentrating on the shunt. Input means shunt means current. So feedback output will also be a current If, and the output is the voltage. Current series, so series means voltage, so it will be the Vf, but our actual output is current, so it is I naught. Current shunt means current, so it is If by I naught. Gain with feedback, it is same with that of the gain without feedback, but the denominator will be changed. That is, gain with feedback is nothing but, for voltage series, V naught by Vs. For voltage shunt, V naught by Is. Current series I naught by Vs, and current shunt I naught by Is. So this is a voltage series feedback circuit. First, we will deduce the voltage gain of each topology, and then we will discuss the effect of the negative feedback onto the input as well as the output impedance. First, gain. Here we will observe that A is nothing but V naught by Vi. AF is gain with feedback. It is equals to V naught by Vs, as we have already observed in the previous table. So AF is nothing but equals to V naught by Vs. Vs equals to, or I can say Vi equals to Vs minus Vf. Vi equals to Vs minus of Vf. Vf is the feedback voltage, and Vf is written as beta V naught because it is the voltage. So putting down the value here, V naught equals to, if you see, V naught equals to A into Vi. So V naught can be written as A into Vi. Vi means Vs minus Vf. So we have written down this A into Vs minus Vf. Now inserting A within the bracket, so AVS minus AVF, but as VF equals to beta V naught, so it becomes A beta V naught. Now it is V naught, it is A beta V naught, taking common V naught, 1 plus A beta equals to AVS. Now as gain with feedback is equals to V naught by Vs, so after manipulating the expression, V naught by Vs equals to A by 1 plus A beta, which is nothing but the AF. Now if we see the two expression, obviously the AF is lower than the A, because the A beta is added with 1. So the result will be, the denominator will be higher than that of the numerator. So AF will be lower than the A. So what we have learned, that using the voltage series negative feedback, the voltage gain is decreased. Next, we are going to the voltage shunt. Voltage shunt means output is voltage, input is current. So first we have write down the amplifier gain A. A is the output by input, that means V naught by II. A is II. Now AF is equals to gain with feedback, so it is written as V naught by IS. So when we are concentrating on the gain with feedback, always introduce the actual source, but when we are dealing with the amplifier gain, we just concentrate on the input signal across the amplifier. Now II means the resultant current from the IS, because one current is going through the feedback circuit, that is the IF. So II can be written as IS minus IF, and IF is derived from the output voltage. So IF can be written as beta into V naught. So feedback is the current. Now V naught is equals to A into II. II means IS minus IF. So after manipulating, it becomes V naught into 1 plus A beta into AIS. So V naught by IS is equals to AF. So it is equals to A by 1 plus A beta, which is also less than A. Now this circuit, in the previous circuit is called, we will see that the gain is a ratio of two voltage. So it is called a voltage amplifier, just like your RC coupled amplifier, etc. But when we are dealing with voltage shunt, we will see that the input signal is current, whereas the output signal is voltage. So it is called I2V amplifier or trans resistance amplifier. Why trans resistance? Because output is V, input is I. So transfer means output by input. So V by I means resistor. That's why it is called trans resistance. Now in the next third topology, which is current series. Current series means output is current and the input is voltage. So A, the voltage gain is equals to current output by input. So I naught by VI, where AF is the gain with feedback. So it is equals to I naught by VS. VI is equals to VS minus VF, and VF equals to beta into I naught. As the output is current, so VF is a voltage. So VF is equals to beta into I naught. Now I naught equals to A into VI. VI equals to VS minus VF. VF equals to beta I naught. So after manipulation, I can say I naught into 1 plus A beta is equals to AVS. So I naught by VS equals to A by 1 plus A beta. Now I naught by VS is nothing but the AF. So AF equals to A by 1 plus A beta, which is less than A. So this type of circuit is called V2I amplifier or transconductance, because we are getting the current from input voltage. So it is called transconductance amplifier. The last topology is the current shunt. The input is current, output is also current. So amplifier gain A is I naught by II. AF, that is the gain with feedback, is equals to I naught by IS, where II equals to IS minus IF, and IF is equals to beta into I naught. Now putting down the value, that is I naught equals to A into II, that means I naught equals to A into IS minus IF, and putting the value of IF here beta I naught. So after reorganizing the expression, it becomes I naught into 1 plus A beta equals to AIS. I naught by IS equals to AF, that is equals to A by 1 plus A beta, which is also less than A. So this is also, this circuit is called current amplifier. So we have observed that in four topologies, the voltage gain or current gain, whatever it may be, it is decreased than the normal amplifier without any feedback. So the negative feedback will result the decrement of the gain. Now we will study the effect of feedback on input impedance, because when we are designing any transistor amplifier, the four parameters are very important. One is input impedance, second one is the output impedance, third one is the voltage gain, fourth one current gain. Because the input impedance is so important that it can protect the circuit from unwanted signal, number one. Number two, uh, it will provide the isolation from the other device to the main circuit, so that any electrical disturbance will not hamper its operation, like that. So first, introduce the voltage series negative feedback. It is a well-known circuit to all of us. Let's see. Voltage series. See, voltage, so output is voltage signal. It is taken to the shunting and going to the feedback circuit. The feedback output is also a voltage signal, VF equals to beta into V naught. Now, input side is also a voltage signal. So our main signal is Vs. It is this portion, the amplifier is represented by a voltage amplifier, because in our previous slide, when we have just discussed the voltage gain of a voltage series, I have mentioned it is a voltage amplifier. That means this amplifier is nothing but a voltage amplifier, and the equivalent circuit of any voltage amplifier will be looks like this, that it has a series resistance Z, it has an input resistance Zi, and there is a voltage source which is connected to a series output resistance. So therefore, what is happening, that this Vs is connected with the input side and the output is connected to the load side. So now we will just deduce for input impedance, what is seen, this is Zi. Zi is the input impedance of the amplifier without any feedback. In RC couple, the Zi was R1 parallel R2, that is a bias resistance, parallel HIE, right? So the same resistance is depicted here also. But now we will study the introduction of this feedback circuit onto this Zi. What is the effect of Zi? Is it increasing or will it be decreasing? However, first we will go to the analysis. II means the input current. II is equals to VI by Zi. II means because it is a series path, this voltage is connected with the series of the Zi. So II is equals to VI divided by Zi, because from this portion the input signal is VI, but at this portion the input signal is Vs. So Vi is produced due to this subtraction of the Vf. So therefore I can say the input's current II is equals to Vi by Zi. Now Vi means Vs minus Vf into Zi. Vs minus, now Vf can be written as beta into V naught by Zi. Now V naught means, what is V naught? Output signal. V naught is represented as AVI. Why? Because this output is impedance Z naught is taken to be very few ohms for an ideal voltage amplifier. So therefore the V naught can be written as AVI. So that's why it becomes A beta Vi by Zi. So II into Zi equals to Vs minus A beta Vi. Now Vs is equals to II into Zi plus A beta. Vi again equals to II into Zi. So instead of Vi, I can write II into Zi. So II Zi will be taken common. It becomes 1 plus A beta, and II is shifted to the denominator of this fraction. So thus Vs by II becomes Zi into 1 plus A beta. Now let's again go into the circuit. Vs is the actual input. The current is in series, so it is II. So Vs by II is nothing but the input impedance of the entire circuit. So the entire circuit means the with feedback. So Vs by II is nothing but ZIF. So what is observing that ZIF is increased from the input impedance without feedback. So for voltage series, the input impedance will be increased. The same phenomena will be observed for the current series case also. Now there is a important correlation. Whenever whenever the topology will be the series topology, always the input impedance will be increased. When the topology will be series, always the input impedance will be increased. It is a common phenomena. So that's why I will not discuss the current series case also. Now we are going to the voltage shunt because the input is quite different, shunting. So these are the equivalent circuit. Now first let us think out voltage shunt. Voltage shunt means output is voltage. So output is taken as a shunting condition to the feedback circuit. Input is the current. So therefore it is nothing but the I to V converter, that is the current to voltage converter. That means the input portion should be a current, whereas the output portion will be a voltage. Now, if we see the amplified equivalent circuit, we will see that it is a I to V converter. So it is a voltage amplifier ZI, just like this is a voltage source with the series output resistance, but the voltage is represented is A into II, not previously it was represented A into Vi, because that time it was series. Now as it is shunt, so it must be written as A into II, because the input is II. Because the input is II, so it can be saying that it is a I to V converter. Now in I to V converter, again I am telling, when it is I to V converter, the input side is a current and the output side is a voltage. So the amplifier is a voltage amplifier, but it is a trans resistance amplifier. So therefore it is a into II. However, we just move into our main discussion. First, ZI. What is ZI? ZI is the input impedance without feedback. So ZI can be written as, if the voltage, input voltage is Vi, so it can be written as Vi by II. Whereas the input impedance for the entire circuit is written as ZIF. So ZIF can be written as Vi. See, this current source is in parallel with the ZI, so the voltage will remain constant for both II as well as IS. So that's why ZIF is equals to Vi by IS. Please be careful that as it is a with feedback, so always we will consider the actual signal. So it is Vi by IS. Now Vi by IS means II plus of IF. So I have written Vi by II plus IF. Now IF is equals to beta into V naught. Now V naught, what is V naught? V naught is equals to A into II, because the Z naught is very small for ideal voltage amplifier. That's why I have reorganizing the expression ZIF equals to VI by II plus 1 plus beta V naught by II. Now V naught by II is nothing but the gain of the amplifier. So thus it will be written as ZI by 1 plus beta A. Now what is the observation? We will observe that in voltage shunt, the input impedance is reduced from the input impedance without feedback, and it is also very common phenomena for the current shunt also, because as we are dealing, please, it is very interesting thing is that as we are dealing with the input impedance, so always look at the input term. Input term means shunt. For both voltage shunt and current shunt, this is the shunt is the input. So when the shunt is present, whatever the topology, the current or voltage, the ZIF will be always lesser than the main Z. But in case of series topology, the input impedance will always be increased. Next, we will deduce the effect of feedback on output impedance. This is a voltage series feedback. Now, output means this first term, it's a voltage. So, when we are dealing with the output impedance, the voltage series and the voltage shunt, for these two topologies, the derivation will be same. It's very, very interesting and tricky one, that when we are deriving the output impedance, always look at the output term. Output term is voltage for voltage series and voltage shunt also. So when we are dealing with the output impedance, the voltage series and the voltage shunt will employ the same derivation. So in the output impedance derivation, what is the method? First, we will introduce an external voltage V at the load side, and we will short the external input signal. So that means the added new voltage will control the entire operation of the feedback circuit. We are completely neglecting any effect of the input signal. It is only applicable for deriving the output impedance. So what is happening? V is sending a current I. So what can I write? So I can write that V is equals to I into Z naught plus AVI. So I can write that V equals to I into Z naught plus AVI. Now, as I have told that Vs must be shorted to ground. So when it is shorted, automatically the Vs will be 0. So when Vs will be 0, it becomes a shorted wire. So Vf, so this negative will be connected directly to the positive, and the this negative will be connected to the positive. So Vi is nothing but equals to minus Vf. So Vi equals to minus Vf. Now, instead of Vi, I have put down this minus Vf here. So V equals to Iz naught minus AVF. Vf equals to beta into V. Here I have not written V naught because there is no output signal. So Vf can be written as beta into V. Okay. So V, here V, and this is here also A beta V. So V is taken common. 1 plus A beta equals to Iz naught. Now V by I equals to Z naught by 1 plus A beta. It's fine. Now what is V by I? If we go to the circuit, V by I, V is sending a current to the circuit. So V by I is nothing but the output impedance of the entire circuit. So Z0F is equals to Z0 by 1 plus A beta. So as 1 plus A beta is a higher term because it is a summative term, so Z0F will be less than Z0. So we had observed for the voltage series, the input impedance was increased, but output impedance is decreased. And for the voltage shunt also, the output impedance will be increased due to this voltage term. Last, we will go to the current shunt, current series, because the output is now current. Now it is the current series circuit. As current series means I to V to I convergence transconductance. So the output is the current amplifier. So this is the equivalent circuit of the amplifier. I naught is the current sourse whose parallel with the Z naught is the output impedance of the amplifier without feedback. So what is happening again? I am connecting a external voltage V and shorting the VS. So V is sending a current I. So I can say I is equals to V by I. I is equals to V by Z naught minus I naught or AVI, because the direction of this current is just opposite with this I. So I can say I is equals to V by Z naught minus AVI. So I equals to V by Z naught minus AVF. Why AVF? As Vs equals to 0, so Vi can be written as VF. So I is equals to V by Z0 minus A beta I. Why A beta I? Because VF is the feedback voltage, but our output is the current, as it is a current series. So output is current. So I beta into I is nothing but the VF. Okay. So in the left hand side, this is the term I. In the right hand side, this is a term of A beta I. So I is taking common 1 plus A beta is equals to V by Z naught, and the Z naught, after cross multiplication, I can write Z naught into 1 plus A beta equals to V by I. V by I is nothing but the Z naught F. So Z0 F is equals to Z naught 1 plus A beta. So what is the observation? The observation is that the output impedance will now be increased from the previous without feedback case. So this phenomena is also common for the current shunt feedback. So what is the summary? That when we are dealing with the input impedance, always focus on the input parameter. Input parameter is the series or shunt. So when the input parameter is the series, always the input impedance will be increased, whatever may be the output. When input side is the shunt, the input impedance will be reduced. But when we are dealing with the output impedance, focus on the output term. Output term is voltage and current. So when voltage is present, output impedance will reduce. When the output term is the current, output impedance will be increased. So this is a very fantastic and interesting to remember. And thank you all for listening my lecture.